In computer programming, code smell is any symptom in the source code of a program that possibly indicates a deeper problem. Code smells are usually not bugs, they are not technically incorrect and do not currently prevent the program from functioning. Instead, they indicate weaknesses in design that may be slowing down development or increasing the risk of bugs or failures in the future. Often the deeper problem hinted by a code smell can be uncovered when the code is subjected to a short feedback cycle where it is refactored in small, controlled steps, and the resulting design is examined to see if there are any further code smells that indicate the need of more refactoring. From the point of view of a programmer charged with performing refactoring, code smells are heuristics to indicate when to refactor, and what specific refactoring techniques to use. Thus, a code smell is a driver for refactoring. The term appears to have been coined by Kent Beck on Ward's Wiki in the late 1990s. Usage of the term increased after it was featured in refactoring, improving the design of existing code. Code smell is also a term used by agile programmers. Determining what is and is not a code smell is subjective, and varies by language, developer and development methodology. There are tools, such as CheckStyle, PMD and Find Bugs for Java, to automatically check for certain kinds of code smells. Common code smells, duplicated code, identical or very similar code exists in more than one location. Long method, a method, function, or procedure that is grown too large. Large class, a class that has grown too large. See God object. Too many parameters, a long list of parameters is hard to read, and makes calling and testing the function complicated. It may indicate that the purpose of the function is ill-conceived and that the code should be refactored so responsibility is assigned in a more clean-cut way. Feature envy, a class that uses methods of another class excessively. Inappropriate intimacy, a class that has dependencies on implementation details of another class. Refused bequest, a class that overrides a method of a base class in such a way that the contract of the base class is not honored by the derived class. See list of substitution principle. Lazy class/freeloader, a class that does too little. Contrived complexity, forced usage of overly complicated design patterns where simpler design would suffice. Excessively long identifiers, in particular, the use of naming conventions to provide disambiguation that should be implicit in the software architecture. Excessively short identifiers, the name of a variable should reflect its function unless the function is obvious. Excessive use of literals, these should be coded as named constants, to improve readability and to avoid programming errors. Additionally, literals can and should be externalized into resource file scripts where possible, to facilitate localization of software if it is intended to be deployed in different regions. Callback, a callback that is trying to do everything. Cyclomatic complexity, too many branches or loops. This may indicate a function needs to be broken up into smaller functions, or that it has potential for simplification. See also, anti-pattern, list of tools for static code analysis, references. External links. Code smell at c2.com, taxonomy of code smells, overview of many code smells.